Imagine standing beneath a sky that hasn't existed in 66 million years, watching a Tyrannosaurus rex close its eyes. Not to sleep. Not yet. Just close them. For a second. Maybe two. What happens in that darkness? We've spent decades asking what dinosaurs looked like, how fast they ran, what they ate. But there's a question almost nobody asks, because it sounds almost absurd. Did dinosaurs dream? And if they did, what could a Tyrannosaurus possibly dream about? For most of scientific history, the answer would have been simple: no. Dreaming requires REM sleep. REM sleep requires a certain kind of brain, mammalian, warm-blooded, complex. Dinosaurs, we assumed, were closer to modern reptiles. Cold-blooded. Instinct-driven. A crocodile doesn't dream. So why would a velociraptor? That assumption held for a long time. It was comfortable. It kept dinosaurs at a safe distance from us, dangerous, ancient, but ultimately simple. Machines made of scale and appetite. Then the evidence started getting inconvenient. Here's the first crack in that comfortable picture. In 2016, paleontologists studying a small dinosaur called Mei Long found something that stopped them cold. The fossil was curled up, head tucked beneath its arm, in almost exactly the sleeping posture of a modern bird. Not sprawled. Not frozen mid-stride. Tucked. Composed. Resting the way a bird rests when it feels safe enough to power down its guard. That single posture reopened a question science had quietly closed. Because birds, every pigeon on every windowsill, every crow in every parking lot, are dinosaurs. Not descendants in some poetic sense. Actual living dinosaurs, biologically and taxonomically. And birds dream. We know this because we've measured it. Zebra finches, when they sleep, show brain activity that mirrors the exact neural pattern they used while learning their songs while awake. Their brains, in sleep, sing the song again. Silently. Internally. Rehearsing. If a finch can replay its song in the dark behind its own eyes, what does that mean for the ancestors that gave it a brain? This is where the story gets strange. Sleep, it turns out, isn't a single switch, on or off, awake or unconscious. It's layered. There's slow-wave sleep, the deep, restorative kind. And there's REM sleep, the strange, twitchy, emotionally charged kind, where the eyes move rapidly beneath closed lids and the mind builds entire worlds out of memory and fear and desire. For a long time, scientists believed REM sleep was something only mammals and birds possessed, a late evolutionary invention. But then researchers turned to an animal nobody expected, the bearded dragon. A lizard. A reptile, cold-blooded and ancient in its own lineage, about as far from a Tyrannosaurus's warm-blooded cousins as you can get on the family tree. And when scientists monitored its brain during sleep, they found something they weren't supposed to find. Cycles. Alternating patterns. Something that looked uncomfortably close to REM. If a lizard's brain can slip into something dream-adjacent, the walls we built around who gets to dream start to look less like biology and more like assumption. So picture it again. Not the monster from the movies. A Tyrannosaurus rex, 67 million years ago, settling its enormous body into the undergrowth as the sun drops. Its ribcage rising and falling. Somewhere behind its skull, in a brain larger and more structured than we once gave it credit for, electrical storms begin. Patterns firing. Replaying. Replaying what? This is where paleontology has to lean on something science usually avoids: inference through kinship. We can't put electrodes on a fossil. But we can look at where dinosaurs sit on the tree of life, flanked on one side by birds, who dream vividly, and on the other by crocodilians, whose sleep is stranger and shallower than either. Dinosaurs sat between those two worlds for over 100 million years. Which means the honest answer isn't yes or no. It's probably somewhere in between. And that in-between space might be the most interesting place of all. Because here's the twist most people never consider. We tend to think of dreaming as a luxury, something evolution builds only after survival is handled. Something ornamental. A daydream is a soft word for something we treat as unimportant. But that's backwards. Increasingly, researchers studying sleep across species believe dreaming isn't decoration. It's rehearsal. Young animals, birds, mammals, even some reptiles, show heightened REM-like activity early in life, at exactly the age when they're learning to move, to hunt, to recognize danger. The theory is unsettling in its simplicity. The sleeping brain runs simulations. It practices. A predator that dreams of the chase may wake up better at the chase. Which means the question isn't really, did dinosaurs dream? It's, did evolution need them to? And if a hatchling Tyrannosaurus needed to survive its first year in a world of larger predators, ambush attacks, and unfamiliar terrain, A world where one wrong move meant it never grew up, then a brain that could rehearse danger while unconscious wouldn't be a luxury. It would be a weapon. Let's slow down here, because this is where the story stops being about biology and starts being about something closer to us than we're comfortable admitting. If dinosaurs dreamed even in some primitive form, what filled those dreams? We can't know specifics. No fossil records a nightmare. But we can look at what dreaming animals today dream about, and the pattern is almost eerily consistent. Not abstract nonsense. Not random noise. Rats that ran a maze that day dream about the maze. Finches that sang that day dream the song. Dogs, twitching in sleep, appear to relive the walk, the chase, the moment at the door. Dreams, across species, tend to replay what mattered most while awake. So what mattered most to a Tyrannosaurus? Not abstraction. Not language. What mattered was the hunt. The chase. The kill. The sound of something moving in the dark that might be prey, or might be a rival twice its size. If dinosaurs dreamed, the leading theory suggests their dreams weren't peaceful. They were rehearsals of violence, fear, and hunger. The same forces that shaped their waking hours would have shaped their unconscious ones too. There's a discovery that makes this even harder to dismiss as speculation. In China, paleontologists uncovered the fossil of a small theropod, curled defensively, frozen mid-tremor, in volcanic ash that buried it in seconds. Scientists studying the specimen noted the posture wasn't just sleeping. It resembled a startle response, the exact posture a modern bird adopts when jolted awake by sudden danger. Which raises an almost unbearable possibility. What if that animal wasn't caught mid-waking panic, but mid-something else? What if, in its final unconscious moments, its brain was already firing through some private, internal alarm, dreaming of the very danger that was, in that instant, becoming real? We'll never know for certain. But the fact that we can even ask the question, and have it taken seriously by working paleontologists, tells you how far this field has traveled from dinosaurs were simple lizards. Here's the second twist, and it's the one that should really unsettle you. We like to imagine dreaming as something almost spiritual, proof of a rich inner life, proof of a mind capable of imagination, memory, maybe even something like hope or dread. We reserve it, quietly, for creatures we consider advanced. Humans. Maybe dolphins. Maybe elephants. Certainly not something with a brain the size of a walnut, like some of the smaller dinosaurs. But dreaming, biologically, doesn't require a large brain. It requires a specific kind of circuitry, and that circuitry appears to be ancient, not advanced. Some researchers now argue that REM-like sleep may predate the split between reptiles, birds, and mammals entirely, meaning it wasn't invented by intelligence. It was inherited by it. We didn't dream because we became smart. We may have become smart, in part, because something in us has always dreamed. That reframes everything. Dreaming isn't a reward for evolutionary sophistication. It might be one of the oldest tools evolution ever built, a private world where a creature could fail safely, rehearse the hunt, replay the escape, before any of it had real consequences. Which means that somewhere in the Cretaceous underbrush, a small, feathered dinosaur curled beneath a fern, twitching almost imperceptibly in its sleep, may not have been having a simple, mechanical rest. It may have been somewhere else entirely, running from something or toward something, in a world built entirely out of memory that existed nowhere except behind its own closed eyes. And that brings us to something harder to shake off. If a dinosaur could dream, even in some raw, primitive form, did it also fear? Did the same neural machinery that lets a brain replay the hunt also let it replay loss? We know some dinosaurs lived in social groups. We know some nested guarded eggs, returned to the same sites year after year. If a mother Maiasaura lost a nest to a predator, and if her brain was wired closely enough to a modern bird's to dream at all, was there a night, weeks later, where something in her stirred, and for a moment, in the dark, she was back at that nest again? We can't answer that. No fossil will ever confirm it. But the question itself is the point. For most of history, we drew a hard line between animal and us, instinct on one side, inner life on the other. Every new discovery about sleep, about brains, about behavior, chips away at that line a little more. Not because dinosaurs were secretly human, but because the line was always blurrier than we wanted to admit. Maybe the real discovery here isn't about dinosaurs at all. Maybe it's about the assumption we carry into every question we ask about the ancient world, the assumption that consciousness, memory, and inner experience are recent inventions, things that showed up late, dressed up in mammal fur and human language. The fossil record keeps suggesting otherwise. It keeps suggesting that somewhere in the dark, behind the closed eyes of creatures we've spent a century imagining as mindless killing machines, something was already happening. Something private. Something we'll never see. So the next time you picture a Tyrannosaurus rex, don't just picture the teeth, the roar, the chase. Picture it at rest. Ribs rising and falling in the dark. Somewhere behind its skull, a storm of electrical signals no fossil could ever record. And ask yourself the question that started all of this, except now it's heavier than before. If something that lived 90 million years before the first human ever stood upright could close its eyes and, for a moment, go somewhere else, what does that say about what a mind actually is?